Hey everyone, welcome to this explainer on NCP-MCI 7.5 Objective 10.2, the 4 policy types. If you're an infrastructure admin gearing up for the Nutanix NCP-MCI 7.5 certification, well, you are in exactly the right place. Today, we're going to set a steady, deliberate pace to completely master Objective 10.2. This covers flow network security and, most importantly, the 4 distinct policy types that you absolutely need to know inside and out. So grab your notepads because we're going to break this down logically and make sure you are 100% prepared. Okay, let's dive into this. Here's our strict 4-part roadmap for today's explainer. First, why flow policies actually matter. Second, a walkthrough of the 4 policy types. Third, exam traps and edge cases. And finally, the key facts you need to memorize. Section 1, why flow policies matter. You know, before we start memorizing the how, it's absolutely crucial that we understand the foundational why behind flow network security, or FNS. At the very heart of flow network security is this concept of zero trust. Now, traditional security models, they kind of operated like a castle with a moat, right? Hard on the outside, but once you were inside the perimeter, you were implicitly trusted. Well, zero trust flips that entirely. It's centered on the belief that organizations literally shouldn't automatically trust anything inside or outside their perimeters. Instead, you have to verify anything and everything trying to connect to systems before granting access. This is the core philosophy driving everything we're about to discuss today. So, how do we actually execute this zero trust model? Nutanix uses categories and category sets. Think of a category set like a giant logic puzzle. It's a collection of categories evaluated with a logical AND operation. This resolves to a specific set of virtual machines, or VMs, where all those categories are assigned. Why is this a game changer? Because security policies in Flow are applied logically to these categories, not to the individual VMs themselves. This means your security scales automatically. Seriously, it doesn't matter if you spin up 2 VMs or 2,000 VMs in a given category. That traffic is secured without any extra administrative intervention. And this brilliantly illustrates the difference between a workload-centric approach and your legacy network-centric approach. Network-centric security requires this really intimate knowledge of VLANs, subnets, and honestly, heavy involvement from network security teams every single time something changes. Flow network security, on the other hand, uses a workload-centric approach. Because policies apply to categories, it can scrutinize traffic to and from VMs no matter how their underlying network configurations change or where they physically move in the data center. This empowers you, the virtualization admin, to implement zero trust independently. No more constantly buying donuts for the network team just to get a simple firewall rule changed. Section 2, walkthrough of the 4 policy types. Let's move into our second section and see how all this builds into the core of Objective 10.2. First up, we have the Application Security Policy. You're going to use this when you want to secure a multi-tier application by explicitly specifying allowed traffic sources and destinations. Out in the field, this is typically called application ring fencing. The absolutely crucial thing to remember here for the exam is that it uses an allow list. That's a least privilege model. It automatically denies everything by default, and you, the admin, must explicitly define exactly what is allowed. You can even get highly granular here, specifying exact protocols and ports. For example, explicitly allowing only port 3306 traffic from your web tier category to your database tier category, while implicitly denying everything else. The second type is the Isolation Environment Policy. You use this when you need to draw a hard line in the sand and block all traffic, completely regardless of direction, between 2 groups of VMs identified by their category. Think of a concrete example. Imagine completely isolating a category named Environment Sandbox from Environment Production. VMs within the sandbox can talk to each other just fine, but they absolutely cannot talk to production. No way. Mechanically, this isolation happens all the way down at layer 2. It drops all ingress and egress broadcast, unknown unicast, and multicast traffic at the destination VM group. It even blocks IPv6 traffic natively and by default. Policy type number 3 is the quarantine policy. For the exam, you absolutely must know the difference between its 2 modes, strict and forensic. Strict quarantine is exactly what it sounds like. It completely isolates the infected VM from all traffic, 0 exceptions. The system even puts a little red icon next to the VM name in Prism Central so you know for sure it's locked down tight. Forensic quarantine, on the other hand, isolates the VM from general traffic but deliberately leaves a secure backdoor open. It permits traffic strictly from categories containing your diagnostic and forensic tools. This lets you investigate a breach without risking the rest of the network. Our fourth and final policy type is the VDI policy, which powers ID-based security. This is essentially an identity firewall. Let's trace the step-by-step logic here. First, a user logs into a virtual desktop infrastructure, or VDI/VM, using their Active Directory credentials. Second, Prism Central detects this logon event. Third, Flow dynamically and automatically places that VM into a category that matches their imported AD group. And finally, the VDI policy automatically enforces rules based on that group membership. It literally maps user identity directly to network security on the fly. Section 3, Exam Traps and Edge Cases. Okay, so we've covered the mechanics, but the exam isn't just going to ask you for basic definitions. Let's pivot to test-taking strategy and look at some things that can trip you up. So, the crucial point here is understanding what happens when policies overlap. Notice this specific priority rule. If VMs are part of both an isolation policy and a quarantine policy, the quarantine policy takes priority of processing. Let's actually apply this. Say you have an isolation policy blocking App 1 from App 2, right? But then a VM in App 1 gets put into a forensic quarantine, which explicitly allows communication with forensic tools located in App 2. What happens? Well, the traffic will flow. Quarantine fundamentally overrides isolation. Keep that hierarchy completely locked in your mind. Here's another highly testable limitation regarding hypervisor support. Nutanix Flow solely supports the Acropolis hypervisor, or AHV. If you get a scenario on the test asking you to apply Flow policies to ESXi or Hyper-V nodes in a mixed cluster, the answer is just a flat no. You cannot do it. Flow network security is exclusively an AHV feature. And this brings us to a massive technical trap regarding VDI policies and Active Directory integration. The Flow ID firewall fundamentally requires a standard, unencrypted, lightweight directory access protocol, or LDAP connection, that's on port 389. The system flat out does not support secure LDAP-S encrypted connections on port 636. If a question suggests configuring secure LDAP-S for ID firewall, you'll know immediately that the configuration will fail. Section 4. Key facts to memorize. We are entering our rapid-fire final section. I've extracted the absolute highest yield concepts from the source material for you. Take a moment and really absorb these 4 golden rules. Consider these your exam cheat codes. Number 1, quarantine policies are system-defined. You cannot create a new one, and you cannot delete the existing ones. You can only modify them. Number 2, if a VM has an apt type category assigned to it, it completely bypasses ID-based security categorization. Number 3, because a user can be in multiple Active Directory groups at once, a VDI VM can be dynamically placed into multiple AD group categories simultaneously. When this happens, the effective policy is a union of all the inbound and outbound rules across those groups. And finally, number 4, remember that Layer 2 isolation drops IPv6 traffic natively and by default. To wrap up this explainer, I want to leave you with a provocative architectural question to chew on as you study. Knowing these 4 policy mechanisms, application ring fencing, L2 isolation, strict and forensic quarantine, and dynamic VDI identity mapping, how will you map your own virtual environment's Active Directory groups to category sets to implement true zero trust, all without disrupting your live production workloads? Pondering that real-world application is absolutely the best way to ensure you truly grasp Objective 10.2. Thank you so much for joining me. Keep studying hard and good luck on your certification.